Hello everyone, thank you all for joining me today. It is January 8th. Today I'm working on LeetCode problem 865, smallest subtree with all the deepest nodes. Given the root of a binary tree, the depth of each node is the shortest distance to the root. Return the smallest subtree such that it contains all the deepest nodes in the original tree. A node is called the deepest if it has the largest depth possible among any node in the tree. The subtree of a node is a tree consisting of that node plus the set of all descendants of that node. The depth of each node is the shortest distance to the root. Okay, small subtree that contains all the deepest nodes. We return the node with a value 2, colored in the yellow in the diagram. The nodes colored in blue are the deepest nodes of the tree. They're at 1, 2, 3, 4, the fourth level. Notice that nodes 5, 3, and 2 also contain the deepest nodes, but node 2 is the smallest subtree. I see, so it is a subtree containing 3 nodes. 5, 2, 7, 4 is a subtree containing 4 nodes, and 3 contains 5 nodes. So we want the tree that contains the deepest nodes and is the smallest subtree. But I'm wondering, doesn't it stand to reason that the deepest nodes, or that the smallest subtree would be the tree with both the deepest nodes and just the parent node? So wouldn't it make sense just to return the parent node such that it contains all the deepest nodes in the original tree? Wait a second, but that's not necessarily true, because in this example that works, but say there was say 8 also had nodes 1 and 10, for example, then 3 would be the node containing all the deepest nodes and not 2, because these 2 child nodes they would be included in that. So we need the subtree with all of the deepest nodes. So yeah, so that similarly, if 7 and 4 were removed, then 6, 2, 0, 8 would be the deepest nodes. Therefore, we would return 3. So I need to find a way to get to the deepest nodes, or get to the deepest nodes in the tree, while being mindful of other parts of the tree having that same depth. Okay, so say 6 had a node of 1, and say I'm traversing the left part of the tree, starting from 3, 5, 6, and we get 1. we could, okay, we could track what the current deepest node is, and then also track what the deepest level is. And if the deepest level is greater than the current deepest level, then we forget about the nodes we were tracking before, and we put in the I was going to say we put in the new deepest node, but we don't need to return all the nodes. We're returning the subtree. So that's an important distinction. Like if this had 6 and 1, I would need to say this has a level of 4, 1, 2, 3, 4, and that is the current max level. And then when we go up, up, and traverse down to 7, that has a level of 4. And then we need to go right, and that has a level of 4. Go up, up, and that'd be 5. So if the two child nodes, assuming they have two child nodes, if both of them return a depth that is the same, assuming 6 has a child node of 1, and 2 still has 7 and 4, a depth can be returned. 4 goes all the way up to 5. Excuse me, a depth of 4 gets returned to 2, which gets returned to 5. And then likewise 4 gets returned from 1 to 6 to 5. They both have a depth of 4. If left or right are greater than the max level, then it makes sense to set the parent node of 2 equal to the min subtree. I think that makes sense. So max level is 3. Let's pretend there's not a 1, the node 1 that I previously talked about. So this path there's 3 nodes. This path there are 4 nodes. And that's the max depth. This path there are 4 nodes, max depth. We'll return 4 from 7. From node 7, we'll return 4 to node 2. This 4 will also be returned from node 4. And so if left is greater than the max level, or right is greater than the max level, then node 2, their parent node, is the new subtree. Min subtree equals to the node. Okay, so that works here. And current level is just, it's being sent to left and to right. So we can remove this. And we also need to say max level equals to current level. Well, we'll say max level equals the max between left and right. Because left could be 2, right could be 10, for example. So intuitively, that makes sense. However, in the instance that on the right part of this tree also has nodes, say 5 and 6, then how are we going to ensure that the node we return is not node 2, not 0, but instead 3? So that's a problem. If it's greater than the max level, okay, and max level here was 4, but say we have 5 and 6, and that would mean that left and right, in the case of the hypothetical subtree 0, parent node 0, and child nodes 5 and 6, that would mean that left and right child nodes of 0 are also they also create a level of 4, a depth of 4. So if left or right are equal to the max level, let me just make a little mental note. If left or right are equal to the max level, that would mean that the ancestor node, the node that they share in common, is the node that needs to be returned. And it's the same thing with 2, 7, and 4. If they have the same depth, then 2 is the node that needs to be returned. Okay, so that adds a little bit more complexity. Or maybe there's some way we could simplify this. Well, when we get to 3, so I mean, I believe this part is solved for example 1, but for the hypothetical problem of 0 having child nodes, the left and the right value are still going to be returned once we get to the root node. So we'll know that once we return to 3, the root node, left will have a value of 4, and then right would have a value of 4. Again, hypothetical child nodes of 0. Excuse me. So if that's the case, if left is equal to right and left if left is equal to the right, then does the min subtree equal the node? example that 0 has child nodes. This would have 4, and then this would have 4. If left is greater than right, and the current level is greater than the max level. Is that right? This is part of the problem. The part of the problem when I feel my cortisol levels rising, and I just feel like I'm starting to not black out, but things are getting a bit too convoluted in my brain. I think my intuition is correct though. Okay. We start at 3. We enter the recursive function. Current level is now 2. Current level is 3. 3 equals to... and then we return the current level in here. That's 3. We go to 5 and start traversing down. 3, 4, also, we need to make sure we add that into the function. And then we'll say we return the node. Is that right? I know I've spent 36 minutes on this problem, so I'll probably spend maybe 4 more minutes. I want to think just a little bit about, I could spend a little bit more time on this particular solution, but I want to think if there's something I should have done before, is think about other alternative things I could have done, such as perhaps I was thinking about storing the node. I was going to say storing the node as well as the current level, the level of the node in an array, and then maybe See, now I'm just grasping at straws, I think is the term. We go from 3, 5, 6. Left is 3. And we want to make sure that, well, is it the smallest subtree as well? If left equals to right in the current level, this isn't right if current level is greater than max level and left is greater than max level. Since these are equal to each other, that's fine. The min subtree equals the node equals to 2. But then these are kind of, these conditional statements are a bit conflicting or redundant. If left is greater than the max level, min tree equals 2, max level equals 4. Return the node? Just the node? I don't think so. This is mainly for, well, no, the logic of node 2 checking the depth of their child nodes is the same as the logic of 3 checking its child nodes. And then cur level is cur level isn't even really being used. No, it's being used right here. So that is updating. Min_tree equals to the node. Max level equals the max between left and right. Yeah, this is getting too convoluted. Where are we at? We're at 43 minutes. Okay, I'm going to say it's time that I enter this into ChatGPT and to see where I went wrong. I like to say thank you anyway. I like to say thank you in the prompts just in case AI ends up taking over. At least they know I was courteous. Yeah. Yep, I see that. That is very bad form. Return 0 and none. Depth. Let's see the refactored version. Excuse me. If they have the same deepest level, this node is the LCA. What is that? Least common ancestor? Less min subtree equals the node. They equal the same. It's greater than or equal to the max level. Because they're working upwards. So min subtree equals that node. Max level is left. Else if the max is greater than the max level, and not if left equals to right, so that'll run first. If it's strictly greater than min subtree equals that node, max level equals the max between those. Return the max of left and right. Okay. Original code makes return values. Got it. Deepest nodes 6 and 8. Those will both have depth of 3. 3 is returned. O of n and O of h. What was the space complexity of the other solution? O of h is a wall. Yeah, I can see how this would be more convoluted than the solution they gave me. Now, I will say, and this is an excuse, but I will say I am very tired right now. But if not node, return 0 and none. So left depth, left node are being returned. Right depth, right node returned to the parent. If left is greater than right, we return left depth plus 1 in the left node. And then that just returns the node of the greatest depth. It looks a lot nicer. I have to say that. If left depth greater than right depth. Okay. So, yeah, I think my implementation was, or my conceptually what I came up with wasn't that bad. But, you know, that is the name of the game. This definitely looks a lot neater than what I put, and you don't have to. My solution conceptually, there's a few more things that can kind of get mixed up, particularly this part. Okay, well, that is that. I will paste this in just to get that little happiness of getting a one-day streak. The problem I did the day before, or the problem I was doing earlier, was the dynamic programming problem. It was from yesterday, but yeah, I couldn't get that done, so this is just the next problem. Again, I need to study more about binary trees. But that is all for today, at least all for this recording, and I'll study a bit after this, and that'll be that. Thank you all for watching, and have a great night or morning.